Bismillahirrahmanirrahim. Assalamu alaikum dear students. In this lecture I will talk about CASTEP calculations. So the first thing is, what is CASTEP? CASTEP is basically the abbreviation of Cambridge Serial Total Energy Package. This is basically simulation tool based on DFT, which is integrated in Material Studio. So through CASTEP you can do a lot of calculations. So if you want to bring CASTEP calculation for your system, so from here you can open the interface of CASTEP calculations. When you open the interface of calculation, you get this type of interface in which the first step is setup. And setup, we have the first thing is task, in which we have different features like energy, geometry optimizations, dynamics, elastic constant, TS search, TS conformations, and proper. So basically the energy definition is it is a single point energy calculation that evaluates the total energy of the system for a given structure without changing atomic positions, or you can say that without changing any cell parameters. So through this we can obtain ground state energy, you can obtain charge density and all related parameters without changing any cell parameters. You can say that with a fixed configuration. So the usage of this task for finding the energy of a given crystal or for a given molecule, you can use this task for comparisons, the stability of different structures, for preparing the input parameter for further tasks. You can say that it is the first step before optimization. So after that we have another task, geometry optimizations. The definition of geometry optimization is to bring your structure in a stable state to that configuration of a minimum energy. So through this we can remove unphysical stress, unphysical force on a structure. We can bring our structure to a realistic equilibrium configuration. Through geometry optimizations we can relax our structure for further calculation, like for electronic, for photonic calculations. We can predict the stability of the structures, or we study the defects of the geometry. Through geometry optimization we can do a lot of things. After that we have dynamics. This is basically molecular dynamic simulations where atoms move according to Newton's laws and DFTs. So through this task we can study our system with temperature effect. We can study vibrations and time dependent behavior of atoms in a system. This task we can analyze the thermal effect on a system, diffusion of atom like ionic conductivity, and also we can study phase transitions, but in a finite temperature condition. Okay, so I want to move forward. Elastic constant. Basically compute the elastic toughness by applying small strain to the optimized structure and calculating stress response. Through this we can get information about mechanical properties such as toughness, bulk modulus, shear modulus, and entropy of the structures. Elastic constant is basically used to find the mechanical property of the structure. As I mentioned already, the toughness, bulk modulus, and shear modulus of the structure. If you want to check the molecular stability of the system of your new compound, you can check through elastic constant. If you want to compare theoretical study with experimental one, and if you want to get a lot of mechanical properties, so you can through this task by applying elastic constant, the CASTEP calculation will provide you different mechanical property of the system, but it's required optimized structure. Same wise we have another task with a TS search search. Basically, TS search abbreviate the transition state search. The search for a transition state on a potential energy surfaces between initial and final state of the reaction. So you can use this TS search for finding the reaction pathway. Through this you can study the diffusion behaviors of the atom in a solid. So this is basically chemistry side research. If someone want to find the surface reaction studies, so these the TS and TS conformation and TS research is used for the surfaces reaction studies. After that we have property. So through this task you can find the band structure, density of state, optical spectra, NMR parameters for non-spectra, and charge densities. You can calculate through this task of CASTEP calculation. Through these features you can find all these tasks. CASTEP setup we have another option, quality. Quality option is a shortcut that controls the accuracy of the calculation by automatically setting important parameters like plane wave cutoff energy, cap point, balance accuracy versus computational cost. Higher quality means more accurate result, but also required more memories and CPU times. So we have different levels in qualities like express cores, medium, fine, and ultra fine. Express and cores have low accuracy but also take low computational cost. These two is basically for finding parameters. If you just want to scan your input file, so if you want to test your file, then use express and cores. If you want to do standard calculations, then use medium, fine, and ultra fine, but it is a little bit more costly. If you want to get a result for publications, so you should use medium, fine, and ultra fine, because through these you will get accurate results, but need some times for optimization for calculation. After quality we have functions. Through function we set the set of approximation used for exchange correlation. So in the first step we have different choices like LDA, GGA, MGGA, non-local, and hybrid. LDA stand for local density approximations, and this is basically for those materials which have uniform density, where we can define its use only the local electron density approximation for exchange correlation. It is computationally cheap, very simple, and historically the first function for exchange correlation, and this function is good for metal and very rare use nowadays. After that we have GGA. GGA means generalized gradient approximations. It is basically the improvement of LDA by including the gradient of the electron density. Means it is used for non-homogeneous density of electron. So this is nowadays a standard choice for material simulations. It can balance accuracy and efficiency. This is good for solid and surface molecular. So next we have MGGA. This is basically meta generalized gradient approximations, and this is more accurate. It's count in gradient and density like kinetic energy density. For example, we have a lot of ingredients, so add extra ingredient in this functions for to improve the accuracy. Next we have non-local and hybrid. These basically is very advanced exchange correlations approximations. It will give a very good accurate results, but very much expensive. So we have some of the limitations in GGA and MGGA. So all the limitations are covered by non-local and hybrids. So through this you can calculate a very strong system. Onward, when you select one of these class, you will fix with a function type PBE, RPBE, PW91 and WC, PBE soil and PLYP. So the first one is commonly used for with the GGF and good for solid and surface calculations. After that, if you talk about RPBA, PBA mean reserved PBA function. It basically modify the PBA function for absorption and surface reactions. This is popular for catalytic studies. So when you want to calculate any catalytic studies, you will fix this function with GGA with any class of. Let's depend on your material, on your desire, what you want to calculate in which. So onward, you will select one by one with these class. After exchange correlations, we have a check or uncheck option to use DFT plus corrections method with different choices. We have the different choices, and after that we have expand polarization options with if you want to add non-polarizations, if you want to collinear to all about the spin of the electrons, and if you have three options: non-polarized, collinear polarized, non-collinear polarized. So all these are related with this spin polarization option. If you check on collinear, you will suddenly check. You can check use formal spin or initials with giving initial values, and you can use DFT plus U method. If your material is a metal, you will check on metal. You can add the charge of the material. So through this you can set CASTEP calculations. So for this tutorial, it's enough for today that we learn about setup. Onward, we will talk about more options and further go to electronic properties and controls for CASTEP calculations. So be with me, I will discuss everything in detail. Thank you for watching and subscribe my channel.